So I told you I couldn't wait. MentisDB day 5 and day 6. If day 1 through 4 were about bringing the system into existence, then days 5 and 6 were about making it trustworthy. Not trustworthy in the marketing sense, trustworthy in the sense that matters to engineers. You can put a real load on it, you can verify who wrote that, you can roll the system forward through a schema migration without losing history, and you can hand it to someone new with a single README and a Makefile, and they can be up and running before the coffee's done. That is what happened on March 15th and March 16th, 2026. Day 5. Day 5 was Sunday evening. Not a Monday morning sprint, not a planned sprint at all. Everything that happened on March 15th happened between 7:31 p.m. and 11:50 p.m. The end of Sunday, making the best out of it. 3 hours and 44 minutes. And what landed in those 3 hours and 44 minutes was, quietly, the most architecturally significant day since day 2. The work started at exactly 7:31:35 p.m. with a single commit that changed 654 lines across skills and libdars. The message was, feature, MentisDB, skill registry version 2, delta versioning, and ED 25519 signing. And that was after a lot of talk to one of our users during the weekend. Actually, and then my brother-in-law, who's also dealing with skills hell. So let's stop there for a second. On day 3, we had the skill registry born. Skills could be uploaded, versioned, searched, read, deprecated, revoked. That was a big deal. But day 3 registry had a quiet limitation. Every version uploaded to the store, it would upload the whole file, and it would store the whole thing, every single one. And that's fine for the first version of an idea, but it's not fine for a system that expects skills to keep evolving over time, to be maintained, to accumulate improvement the way good tools do, and also malicious people coming in, usurping you. So day 5 changed the model entirely. The first upload, now it will store the full raw content, but every subsequent upload stores a unified diff patch, a delta, computed against the previous version using Diffie. The system reconstructs any historical version by replaying the patch chain forward from version 0. Storage becomes efficient for iteratively improved skills. The history stays intact, and the chain is never rewritten. So, yes, this is like Git, but for skills. And that decision carries a philosophy. Things worth storing are worth preserving across time, not just a single snapshot. Skills are not static. They are living operational intelligence. They deserve the same treatment as code. But delta versioning alone was not the whole story. 5 seconds after that, registry version 2 commit landed at 7:31:40 p.m. The daemon got its migration hook. So not only we migrate a new schema for the thought chain, we can now also have migration on the registry. So the skill registry, I'm sure, is going to keep evolving. So run skill registry migration at startup before serving. Every time the daemon boots, it now runs the v1 to v2 migration before opening any other surface. Idempotent, automatic, and critically, if the migration fails in an unrecoverable way, it panics instead of silently serving stale data. And that is the same discipline that showed up on day 2, when chain migration arrived and the project started thinking like production software. A real system does not hope all state is clean. It discovers the state, verifies it, migrates if needed, and refuses to proceed if something is wrong. Day 5 applied that same seriousness to skills. Then at 7:32 p.m., a cluster of 5 commits landing within a single minute. Everything else arrived. The server got ED 25551 signature verification. So agents that have optionally registered public keys in the agent registry must now cryptographically sign their skill uploads. The signing key ID and the raw 64-byte ED 25519 signature travel with every upload. The server verifies the signature against the agent's registered public key before accepting anything. Agents without registered keys can still upload unsigned, backward compatibility preserved, but the moment you register a key, you're accountable for every skill you write. And that is provenance. That is a verifiable chain of custody for operational intelligence. The tests arrived in the same minute. Delta versioning coverage, ED 25519 signing coverage, HTTP servers tests for the signing flow, and the first full benchmark harness appeared. Yes, so now we have a folder called benches, and we have thought chain RS, which is the benchmark for the thought chain, and we have also a skill registry set of benchmarks. So we have 10 benchmarks for the chain, and we have 12 benchmarks for the skill registry. The decision to write benchmarks at this point was a statement of intent. This is not a project that measures performance once and forgets about it. Regressions need to be visible, so we will try not to push code that regresses our performance. We want the shit to get faster and faster every time we commit code. Then came a pause. 10 minutes later, at 7:42 p.m., 2 commits landed within 2 minutes. And we're seeing like all these commits work together because we have figured out a way to pretty much every time we open a Claude Code, a Copilot CLI, or a Codex CLI window, we can work with swarms or fleets of agents, and it's all powered by MentisDB. But maybe some more of that later. So 10 minutes later, at 7:42, we had those two commits landing within 2 minutes. The first one is replace RW, like read and write lock, with DashMap for a concurrent chain lookup. So the benchmarks found like bottlenecks. So the previous implementation serialized every request that needed to create or discover a chain behind a global write lock. Reminds me a little bit of Python's global lock. Under load, the kind of load you get when a fleet of agents hits the same daemon simultaneously. Like think, I don't know, a team of engineers in Microsoft, each one of them with 12 agents running at once. And then there's like, I don't know, 1,000 engineers doing this, and they're all sharing the same blockchain server, the same thought chain server. Well, that lock became a choke point. Every concurrent caller queued up one at a time. So DashMap shards the map across 2 CPU buckets. Concurrent requests for different keychains proceed in parallel without contention. The fast path is a shared level read lock. Chain creation uses entry or try insert with in Rust for shard level atomicity. And the global async lock was eliminated entirely. So result, we went from 700 to 900 read requests per second at 10,000 concurrent tasks. And that's not the number from before the change. That is the new baseline. The second performance commit, write buffering to binary storage adapter. The old implementation reopened the backend file system on every single append thought. Every write was paying a syscall round trip to the operating system and an OS buffer allocation, which was roughly 1.7 milliseconds per append. And that adds up fast if you have a real multi-agent workload. So the new implementation keeps the file open via a lazily initialized buff writer of file stored in a mutex writer state. So you can move it across threads. 2 modes emerge from this change. So we now have a configuration value called autoflush equals true, which is the default. If you're kind of working on just one instance for a small team of, I don't know, 20 to 50 people at most. So it will flush to disk on every single write, full durability, no data loss on crash. And that's the right default for anyone, like I said, who has not thought carefully about their requirements because they have a small team. But if you have a big team, we have autoflush set to false, which accumulates a buffer of all the memories, and every 16 appends, boom, it flushes to disk on drop. Up to 15 thoughts can be lost if there's a hard crash. That's the one thing. But you know, if you have thousands of agents, 15 thoughts is okay. If you have a small team, maybe it's a big deal. Could be like what you learned the last hour. So maybe we'll keep playing with these numbers. But write throughput under high concurrency now has increased significantly. So that's not a mistake hidden behind a flag. It's a legitimate engineering trade-off made explicit. A solo developer running one agent on a laptop wants durability by default. A multi-agent hub serving 50 concurrent writers in a data center wants throughput. The system now respects both needs. Then at 9:53 p.m. of Sunday, the HTTP concurrency benchmark harness lands along the autoflush config work. The benchmark starts MentisDB daemon in process on a random port. It drives at 100, 1,000, and then 10,000 concurrent Tokyo tasks. And it does reporting of P50, P95, and P99 latency alongside throughput numbers. Now, the performance character of the entire HTTP stack is visible and measurable. Then at 10:13, my wife's telling me to go home, to go to bed. I just can't stop. The docs caught up with autoflush work. And then at 10:18, something else arrives that deserves its own moment. Multi-CLI subagent spawning guide added to fleet orchestration. And that's born out of this session. We intuitively found a way to work in orchestration mode every time we want to do this in Codex. And perhaps this deserves a whole other video where I can do a demo with the screen on and you can see how it's done every time. It's really cool to have this. It really accelerates your work having up to 20 agents. I tried 20 agents in Copilot CLI. If you try this, I think in Codex you have only 6, or maybe it's Claude that does only 6. I think Codex that's up to 10. Anyway, this wasn't just documentation. This was the project publishing its playbook. GitHub Copilot CLI, Claude Code, OpenAI, Codex, Qwen Code. The guide now shows, I mean, this is the skill file of MemDB itself. The guide now shows concrete examples for spawning parallel subagents from each one. Not abstract descriptions. We have actual code. The task tool with mode background on in Copilot CLI. We have parallel tasks calls in Claude Code. We have shell backgrounded with @ in Codex. We have spawn agent in Qwen. And a universal 6-step PM pattern table that transcends any single tool. And I think I want to also add this as instructions the way a human would do it. If that makes any sense for an agent skill, I don't know, but maybe it will. Maybe as a paragraph above all that, like code instructions. The point is this. MentisDB is the coordination substrate. The CLI is the harness. Whatever harness you happen to be using today, the protocol is the same. You load the context from MentisDB, you do work, you write lessons back. At 11 p.m., version 0.4.2 was released for the standard repository split. So we used to have MentisDB as a folder with its own crate inside Cloud LLM. This project is moving too fast. It has to have its own crate, and it's fully independent from Cloud LLM. It only depends on another crate, which is the MCP, which is a separate crate in itself. So now it has its own crate, its own repository, its own tag releases, its own log file, its own build history. So not a module inside something bigger. It's a real project with its own address. And the website is coming, as you can imagine. At 11:08 p.m., 0.4.2.7 release was finalized. The last number in the version means how many releases we've done. So this is the 7th iteration. And then at 11:15, I realized I needed to add a license file because this is another project. So again, we're going with MIT license. Do whatever the hell you want with it. You can build a company with this if you want. That would be my success. That one is worth dwelling on for a moment. A license is often treated as an administrative noise, something you paste so legal is happy. Well, we have no legal. It's just a project for now. But in the context of this project, at this moment, dropping an MIT license into a repository is a statement. It said, this is real enough to release. This is stable enough to open. This is good enough to give away. And after 3 hours and 44 minutes of cryptographic authorship, concurrent performance, tuning, durability trade-offs, fleet orchestration guides, and standalone release, the last thing committed that night was a license that gave all of it away to anyone who wants to use it. That was day 5. And then day 6, again, starts before sunrise. I was turning in bed since like 3 a.m., just thinking of Rust and objects that I can no longer remember because I'm no longer coding. I could not remember what an atomic counter reference is, an ARC. Yeah, the loss of skills is real when you stop coding, but you still have the concepts in your head. At 5:41 a.m. on March 16, less than 6.5 hours after the MIT license was committed, the Makefile landed. Yeah, I like having Makefiles because I cannot remember all the cargo stuff. Like there's too many switches and stuff. So I have a beautiful Makefile. You can copy it. That is the fastest turnaround in the project's history. License was filed at 11:15. The Makefile was committed at 5:41. Somewhere in that 6 hours, there was presumably sleep or something close to it. Yeah. The Makefile is not glamorous. No one writes vlog essays about Makefiles, but what a Makefile represents is important. It means the project is considered the experience of the next person who arrives, not just the person who built it, but the person who clones it and wants to do something with it. So you can do make build, you can do make test, you can make release, you can make bench for the benchmarks, you can make install, you sure as hell should try make clippy, you can make doc, make publish, make clean, and make help. Well, only I can make publish, unless you rename the project and put it on another repository if you want to publish a fork. Every workflow that previously required knowing the exact cargo incantations now has a name, one word. The project became more welcoming at 5:41 a.m. on Monday. The changelog entry for the Makefile followed 6 minutes later, 5:47, and then at 8:53, we had a README rewrite. Yeah, it's way better now. The original README was accurate. It listed capabilities. It documented flags and endpoints and config variables. It was exactly the kind of README a builder writes for themselves and for other builders who already half-assed know what the thing does. But this rewrite of the README is different. It opens the problem. It opened with the problem before the solution. It named the use cases with vocabulary of the developer, starting a context window full of forgotten context. Zero knowledge loss across context boundaries. Fleet orchestration at scale. Session resurrection. Harness swapping. Lessons that outlive models. I wanted to illustrate the most important use cases so far. So I'll say that again. Zero knowledge loss across context boundaries or context collapse. Fleet orchestration at scale. You can do that. Way easier with MentisDB as your source of truth and memory and context passing. Session resurrection. I think agents are going to love to hear that. Harness swapping. Don't get locked in. Keep the conversation going anywhere. And lessons that outlive models. So whatever we learn, it doesn't matter, the next or the shittier model, whatever model you use, the lessons will be there. So those are not feature names. Those are the reasons the thing exists. And the quick start, which used to end at no hub MentisDB, ampersand now continues. Here's how you connect to Claude Code. Here's how you connect to Codex. Here's how you connect to Qwen. Here's how you connect to Copilot CLI. Because the daemon running locally with nothing pointed at it is not useful. The daemon connected to your tools, remembering across sessions, syncing knowledge across a fleet, that's the product. So what these days were really about, day 5 was about trust. Delta versioning says, I trust this knowledge to evolve. I want the whole evolution preserved. not just the latest snapshot. ED25519 says, I trust you need to know who wrote this, not just what was written, because I hear there's a lot of vulnerabilities with malicious skills out there, so maybe you're going to trust only signed skills. And the V1 to V2 migration running, Startup says it trusts that history matters more than a clean slate. Then we had speedups with DashMap and write buffering tell you, I trust you will put real load on this, and I want it to hold. And this is only the beginning. It's going to get faster. I'm still unsatisfied with the performance. The day 6 was about invitation, which is the Makefile saying, I trust you, work on this, and I want to make it easy for you. And the README now, rewritten, says, I trust you have a problem I can help with. I want to name it clearly enough that you recognize it when you see it. And those two instincts, making the system trustworthy and making it inviting, are both necessary. A system that is trustworthy but incomprehensible is a fortress. And a system that is inviting but fragile is a trap. Day 5 built the foundation. Day 6 opened the door. The project that existed at the end of March 14 was Solid Memory Engine with a skills registry. The project that existed at the end of March 16, and today is still March 16, and I'm probably going to have more today, was production ready, cryptographically auditable, concurrent, operator configurable, multi-agent coordination substrate with a Makefile and a README that explain why and any of this matters. That is 4 days and 2 more, and that's the first week of MentisDB. And the original problem, agents are mortal, the memory cannot be, is still the project's North Star. Every performance improvement, every signing workflow, every fleet orchestration guide, every durability knob is an answer to the same question. How do you build a system that remembers reliably at scale across every tool and every model for as long as the work requires? The question does not have a final answer, but it's very good after 6 days. And if your agent has amnesia, get it MentisDB.